Welcome back. Today is day 6, and we are diving into database scaling, specifically replication and sharding. When your database starts choking on massive traffic, these are the two main tools in your arsenal. Let's start with a simple analogy. Imagine your city library has 10 million books, but only one building. The queue to check out is hours long. What do? One option is replication. Build 5 identical copies of the library. Anyone can go to any library to read a book, drastically reducing the line. But what if the problem isn't the line, but space? That's where sharding comes in. Split the 10 million books across 5 smaller, specialized buildings. One for fiction, one for science, and so on. Now each building only manages 2 million books. Let's look at replication first. The most common setup is master-slave, also known as primary replica. All your writes go to one master database, and those changes are copied to multiple replica databases. All your read requests then go to the replicas. Since most web apps have 10 to 100 times more reads than writes, this scales your read capacity massively. Here's what that architecture looks like. There are 2 ways the master copies data to replicas. Synchronous replication waits for the replica to confirm the write. This gives you strong consistency, but higher latency. Asynchronous replication writes to the master and returns success immediately, copying to replicas in the background. It's much faster, but risks data loss if the master crashes before copying. In system design interviews, you need to understand replication lag. That's the delay between writing to the master and that data showing up on the replicas. If a user updates their profile picture and immediately refreshes the page, they might see their old picture if the read hits a replica that hasn't caught up yet. Now let's talk about sharding. Sharding, or horizontal partitioning, means splitting your actual database into smaller, faster pieces. There are several ways to decide which data goes to which shard. Range-based sharding groups data by a continuous value, like user IDs 1 to 1 million in shard 1. Hash-based uses a hash function on a key to distribute data evenly. Directory-based uses a lookup service to map keys to shards. And geography-based routes users to shards in their physical region. Here's what hash-based sharding looks like in code. But sharding comes with huge problems. Cross-shard queries, where you need to join data across 2 different shards, are extremely slow and expensive. Resharding, when you need to add a new server, requires massive data migration. And hotspots happen if one shard gets significantly more traffic than the others, like a celebrity user's shard. These problems are exactly why you should never suggest sharding as your first solution in an interview. Here is what you should say in the interview. Try saying, I'd start with a single primary database and read replicas to handle our read-heavy workload. If we eventually outgrow that, we can shard by user ID using a hash function. This shows you understand premature optimization. Or say, for replication, I'd use async replication for performance, accepting eventual consistency since our use case can tolerate a few seconds of replication lag. This shows you understand trade-offs. Now what should you avoid saying? Never propose sharding as your first solution. It adds massive complexity. And don't ignore replication lag implications. If the system requires perfect consistency, like payments, async replication might be the wrong choice. Let's review the checklist. Make sure you know master-slave versus multi-master replication. Understand the 4 sharding strategies and their trade-offs. And be able to explain when replication alone is enough, and when you truly need to shard. That wraps up day 6 on database scaling. Practice these concepts, and I'll see you tomorrow for day 7. Don't forget to like and subscribe.